Let's talk about the relationship between stress and strain. Taking that same strain example from before on this very soft material, if I take a look at the cross section of this material, let's say it matches with something we've seen before. It's 2 square inches. So in this example, we can compute both the stress and the strain. Typically we'll use the letter sigma, lowercase sigma, for stresses, and for strain we'll use epsilon. When we have zero load on this, there's zero stress. There's no pressure when there's no load, and we don't have any elongation either. So that'll be a data point on this curve. When we begin applying load, let's say we get to 100 pounds, how much stress do we have? 100 pounds distributed over 2 square inches, 50 psi. So let's say our 50 is here. And how much strain did we have? That was 0.1. So we can begin graphing this relationship between our pressure inside the structure, our internal pressures or stress, and our percent elongations, our strain. Now, let's take a guess here. If I were to double the load, what is my stress going to be equal to now? If you said roughly 100 psi, you'd be right, ignoring the change in the area, which we'll assume is relatively small. Now, how much strain would you guess we would have in this case? If you guessed 0.2, you made what's called a linear assumption, which we'll talk more about in the training class, material linearity. Many materials will behave in the following manner, where they have a linear region on their stress-strain curve, and then a nonlinear region. I've shown you a graph here for steels and aluminums, or many metals for that matter. There's a point where the structure yields, we call this the yield point, and then just a little bit of extra stress causes a large amount of extra elongation. It starts to give way until eventually it reaches a breaking point. Other materials such as plastics and rubbers may not have a really clear, well-defined linear region. Sometimes we can approximate them up to a certain extent, but a lot of times they'll be better to run in a non-linear analysis.